Hi, my name is Matthew Yahov, and today we're going to talk about the ZTNA functionality on the Versa switches. First of all, each of the Versa switches supports ZTNA or Zero Trust, and Zero Trust capability allows you to monitor in the real time your clients, which can be Windows, macOS, Linux, and others. And based on the configuration of the client, we can adjust the behavior of the switch. So we can take into account things such as identity of the user, so his username, his role, his privilege, and also additional features such as version of the operating system, patches that are installed, what is the processes running. So basically, each client can establish control plane connection to the switch, and this control plane connection can pass periodic data about the posturing of the end user device. Meaning that in the real time, if something changes on the client, we can receive this information on the Versa switch and change the behavior of the Versa switch. Now, the interesting thing is that enforcement point is going to be right on the switch if it's a direct connection. What will happen if we have a third-party switch in between the client and the Versa switch? In this case, we can still establish control plane connection. We can still pass the EIP information or posturing information to the Versa switch. So all the information about the client connections, about the encryption on the hard drive, about the processes running, about everything that is happening on the client can be periodically sent to the Versa switch. And also certain parameters such as the most important, such as firewall configuration and others, can be passed in the real time as soon as their behavior changes. But the limitation in this case is that enforcement point is still going to be on the Versa switch, as we cannot control the third-party switches. So the closer your client is located to the Versa switch, the more secure is your environment. So what this means to us? This means that when device is compliant and the switch receives information that it's compliant, device can be allowed to access all the microsegments in the system. But let's say that device becomes out of compliance. So let's say that somebody disabled hard drive encryption and this information was passed to the Versa switch. We can limit access of the endpoint device based on this change on the endpoint or on the client. What will happen if something else, let's say that we disabled firewall? In this case, switch can restrict the device even more. So what we have in total? In the traditional way of things, how usually networks operate, if the device gets compromised, so let's say if something happens on that device, all the machines before the firewall gets affected. The blast radius is huge without ZTNA. While if we have ZTNA configured and the switches are and the ZTNA is enforced. In this case, if something happens to the endpoint, we can restrict that endpoint to the port where it's connected to the switch. So we have the real zero trust where we don't trust anything behind the port of connection to the Versa switch. Let's see how to configure ZTNA on the switch. So here's the template which I'm using for my switches. In this template, we're going to go into the security, and I already have some configuration for the ZTNA, but most of the configuration that was done is upload the certificate which is needed for the connection. So we need a certificate and CA certificate. We need to specify into which VRF we're going to land the clients which are going to be connecting, and basically some basic information about what is the gateway domain name that you will be providing. The second portion in the ZTNA configuration is how we're going to authorize users. We support SAMLess authentication method, LDAP, and local authentication. For this demo, I'm going to be using local authentication. So just to show you, here's where I have two users. One of them is Matthew, second is Clint. They have their passwords, and that's how we enable them to connect to the switch. The second portion is the enforcement. So let's configure enforcement portion. So here we're going to create a new microsegmentation policy. I know that I have some Apple devices, I have some Windows devices with the disabled firewall. I also have some phones in my network. I have some printers, and I have some Windows devices with enabled firewall and just regular Windows devices. So let's see how we can configure configuration between them. So we're going to call this profile ZTNA. By default, only devices within the same microsegment are allowed to communicate with each other. For the demonstration, we're going to say that when we enable firewall, we want to allow communication with the phones. And vice versa, when we have the phones, we want to allow them to connect to the devices with the running firewall. Let's save this configuration, regenerate the workflow. So now we have a new configuration. And lastly, we're going to apply this newly created template to our switches. So we're going to go here, select the switches, and apply configuration. Okay, now let's see how it works. First, we will check what are the current SGTs or microsegments assigned to the devices. So in here, we see that the system has a device with IP address 172.16.100.101, and it belongs to the microsegment called phones. Also, we have device 172.16.200.200, which belongs to the microsegment Windows devices. This is the general microsegment where all the Windows devices are being assigned. So now let's connect to my Windows machine and let's connect to the gateway and see the change in the behavior. Okay, we are connected. So now we're going to see the microsegments and update the screen. Now we see that the microsegment changed to the running firewall. This is the microsegment which came based on the posturing information we received from the client. And actually, wait, looks like the phone updated the IP address over DHCP as well. So anyway, we're supposed to be able to ping 100.102 now based on our new microsegmentation policy. So let's try it. 16.100.102. Okay, we can ping it. You see, this is because of our microsegmentation policy. And now I'm gonna place a permanent ping. So when we're doing permanent ping from this machine to the phone, and now let's change the firewall behavior. So based on the firewall settings, the behavior of the switch should change. So we're gonna go in the firewalling. We're gonna open a firewall setting. We're gonna disable it for domain networks, for private networks, for public networks, all three of them. Yeah, we're getting warning. Now let's wait. It should be up to 10 seconds. 3, 4, 5, 6, 7. That's it, 7 seconds, and it switched. Now it is blocking all the connections. It is blocking because if we're gonna check the microsegment, now this IP has microsegment disabled firewall. So it was able to capture this in real time and start working. Again, I'm gonna demonstrate it again. So if I'm gonna change the firewall behavior to enabled, it's gonna start working in a couple of seconds as well. So we enabled firewall. Let's wait. Oh, it started working right away. So you see, running firewall. So that's how the real Zero Trust works, where we can capture all the information and basically use any parameters on your client machines to control the behavior of the switch. Okay, lastly, I wanted to show you what can be used as the match criteria for the EAP, for the posturing. So in here, let's say we create some rule. Here are the parameters of what we can track on the client machine. It can be the firewall settings, where we have multiple vendors. We can check each of them, their products, their software, whether it's running or not, installed. Maybe we can check the version of the software. We can check the status of the services. We can check things such as, let's say, Windows registry. If the Windows registry changes to any other value, again, we can change the behavior of the switch. If the file is present or not present, or if on your Linux or macOS device or Windows we have certain process which is running or not running, we can change the behavior of the switch if that process is being disabled. So the customization, the capabilities that you have are just immense. I hope this was informative for you, and thank you for watching.